Jai Shri Gurudev. Good morning to everyone, students. The next concept is properties of haloalkanes. You know well, there are two types of properties. There is physical properties and chemical properties. Now take first one, physical properties. So physical properties, under that the first physical property is the boiling point of haloalkanes is higher than that of the corresponding alkanes. For example, observe, take CH3X, that is chloroalkanes or halomethane. This boiling point is higher than corresponding alkane, that is methane. So from methane you get chloromethane or halomethane, right? Here the boiling point of halomethane is higher than that of the alkane or corresponding alkane because the halogen is more electronegative than that of the hydrogen or any other another carbon. Due to that, it has high dipole-dipole interaction. Hence the haloalkanes having high boiling point than that of the corresponding alkane. This is the first physical properties. Then second one, the boiling point of alkanes is increases with increasing the size of the halogen atom. That is iodide. This is high size. Iodine has high size. Therefore, alkyl halide, that is iodine alkane has high boiling point than bromide compound, then chloride compound, then fluoride compound. It means the size of the halogen atom increases, boiling point increases. Size of an halogen atom increases, boiling point increases. Then the third one, primary alkyl halides has less boiling point than that of the secondary and tertiary. It means branch of the alkyl halides increases, boiling point decreases. Branch of alkyl halide increases, boiling point decreases. That is, it has tertiary alkyl halide is less boiling point than secondary alkyl halide, which is less than primary alkyl halide. It means branching increases, boiling point decreases. Then fourth one, the solubility of alkyl halides is less in water. However, it is soluble in organic solvent. That is, alkyl halides are insoluble in water, but soluble in organic solvents such as benzene, toluene, ether, etc. So this is the solubility of alkyl halide. Then the fifth one is density of alkyl halides increases with increasing size of halogen. So you know density, that is rho is equal to mass by volume, right? So mass is nothing but size of an atom. Therefore, size of an atom increases, density increases. These are the physical properties, with some physical properties of haloalkanes. Now take chemical properties. Now the next concept is chemical properties. Under that, first one, nucleophilic substitution reaction. These haloalkanes undergo nucleophilic substitution reaction. So generally the nucleophilic substitution reaction is nothing but, if you take haloalkanes, that is C bond X. This is the general representation of haloalkanes. Let this carbon having 3 substituents. So this is haloalkanes. Here the halogen is more electronegative than carbon. Therefore you get partial negative charge per halogen and partial positive charge per carbon, right? So if any new nucleophile that is represented as Nu nucleophile, you know this nucleophile is rich in electron, right? Or this species which is rich in electron we call nucleophile. Hence this nucleophile get attached to the electron deficient carbon. During that time this halogen is eliminated because more electronegative. You get a compound of the type like, so observe carbon that having 3 bonds, right? And this nucleophile get attached to the carbon, that is bond Nu nucleophile, plus this halogen is eliminated as X minus, that is negative charge. So this type of reaction is called as the nucleophilic substitution reaction. Now there are so many types of reactions, means so many types of nucleophiles get attached to the electron deficient carbon. Those we are seeing one by one. Now take first one, reaction with alcoholic sodium hydroxide or potassium hydroxide. Now the first one, reaction with alcoholic sodium hydroxide or potassium hydroxide. Here NaOH is behaves as, means OH ion port in NaOH or OH ion port in KOH is behaves as nucleophile, that is rich in electron. So take alcohols, haloalkane, that is general reaction, hard bond X. This haloalkane is treated with alcoholic, take NaOH or KOH. NaOH gives, so this Na group get attached to this halogen, hard group, and this halogen and Na becomes NaX, that is this Na and X becomes NaX, and R and OH becomes ROH. So this ROH is general representation of alcohol, and this RX is general representation of water. Alkyl halide are also called as haloalkanes. Alkyl halides. So here by using alcoholic KOH or NaOH, you get alcohols from haloalkanes. This is the chemical reaction, that is chemical property under the nucleophilic substitution reactions of haloalkanes. Now example. So take in place of R CH3 bond in place of X take chlorine. So what its name? Chloromethane, which is treated with alcoholic KOH, that is alcoholic KOH or NaOH, sodium hydroxide or potassium hydroxide. What you get is Na and the Cl becomes water, NaCl, and the remaining thing is CH3OH, CH3 bond OH plus NaCl. So what is name? Methanol alcohol or methyl alcohol. So similarly, observe one more example. Take chloroethane, that is CH3CH2 bond Cl. What is name? Chloroethane, which is treated with water, alcoholic. Either take NaOH or KOH. Now take KOH. Your wish, take any base. Now what you get here? K plus Cl becomes KCl, and the remaining thing is CH3 bond CH2 bond OH plus KCl. So what is name? Ethanol. Okay, so this is the way to prepare alcohols from alkyl halides, or this is the chemical property, one of the chemical property of alkyl halides. Now second one, reaction with potassium cyanide. The second chemical property is reaction with potassium cyanide. This potassium cyanide is a ionic compound. It easily ionizes K plus and Cl minus. Now here alkyl halides, that is RX. this alkyl halides is treated with alcoholic potassium cyanide. Alcoholic potassium cyanide. Here also similarly, this Cn minus ion get attached to this carbon and X will be added to this K, becomes KX. This is a general reaction. So you get carbon Cn plus KX. This resultant compound we call as alkyl nitride, or we also called as cyanides. Alkyl cyanide are cyanoalkanes. Alkyl cyanides are cyanoalkanes. This is a general reaction. So similarly, now take example in place of take methyl, that is CH3, but in place of X take chlorine, that is chloromethane. I hope no need to write the name at every time, because you know the name of this simple compound, that is chloromethane, which is treated with what? Alcoholic potassium cyanide. So what you get, this potassium and chlorine becomes KCl, and the resultant compound is CH3Cl, that is CH3 bond Cl plus KCl. Okay, what is its name? Alkyl nitride, that is methyl nitride or cyanohethane. Methyl nitride or cyanohethane. Methyl nitride or cyanohethane. Cyanohethane is the hyperacne. So its name is ethyl nitride or cyanohethane. Similarly, take one more example. Take CH3 bond CH2 bond Cl. That is called chloroethane, which is treated with alcoholic KCl. So what you get, the resultant product, that is K and Cl becomes KCl, and you get CH3 CH2 and Cl. That is CH3 CH2 bond Cl plus KCl. Okay, so here observe what is name. How many carbons are there? 1, 2, 3. 1, 2, 3, right? So the name is called pro. That is propyl nitride. They are also called as cyano. This group is called as cyano. This group, and the remaining carbons is 2 only. Therefore, 1, 2, ethane. Cyanoethane. Like that, we are giving the name. Similarly, the third chemical property is reaction with the silver cyanide. The chemical property, third one, is reaction with silver cyanide. That is AgCN. So observe here, in this case, in place of potassium cyanide, it means in place of potassium we are taking silver, right? So in place of potassium, if we are writing silver, AgCl, the reaction of this is changes, or the property of this reaction is changes, because this AgCl is covalent compound. In the previous example, I told you this potassium cyanide is what? Ionic compound. Therefore, this potassium cyanide is ionizes easily like K plus and Cn minus. But the silver cyanide AgCN cannot be ionized as Ag plus and Cn minus, cannot be ionized easily, because it is what? Covalent compound. This is ionic compound. Hence, the product of this reaction is changes. That is how it is changes means, if you take a silver cyanide AgCN, Ag and X becomes AgX, and this is becomes interchanges the atoms. That means RCN becomes RNC. RCN becomes RNC, and the resultant compound we call RCN becomes RNC, and the resultant compound we call isonitrile. The resultant compound is called as isocyanide and is called as carbylamine dust. Carbylamine dust. We also called as carbylamine or carbylamine dust, and its name is isocyanide. This is cyanide group, that is called isocyanide. Right? So this is the difference between reaction of potassium cyanide versus silver cyanide. Remember, they will ask, with potassium cyanide, alkyl halides gives nitrile compounds, but with silver cyanide, this alkyl halides gives isonitrile. Give reason. Because the silver cyanides are covalent compound and the potassium cyanides are ionic compound. Hence, after ionizing potassium cyanide, you get Cn minus ion. This easily attached carbon to the next carbon because CC bond is more stable than Cn bond. The CC bond is more stable than Cn bond. Hence, with potassium cyanide gives nitrate, with silver cyanide gives isocyanide. This is the reason. Now take one more example with silver cyanide. So next example, that is take chloroethane, which is reacting alcoholic silver cyanide, that is AgCl. So similarly here, silver and this chloride becomes what? Silver chloride, that is AgCl. And the remaining thing is CH3Cl, that becomes NC, that is CH3NC. What is its name? Isocyanide. Its name is methyl isocyanide. So similarly, take the next example, that is chloroethane, which is reacts with alcoholic AgCl. Right? What are the products you get? Take this is homework. So what are the products you get? Right? Or complete this reaction. Similarly, the fourth chemical reaction is reaction with ammonia. So in the fourth chemical reaction, that is reaction with ammonia, chemical property. Here alkyl halides is treated with ammonia, that is alcoholic ammonia at 373 Kelvin. At 373 Kelvin, this alkyl halides reacts with alcoholic ammonia to get primary amines, that is one hydrogen and one X becomes HX, and the remaining is our bond NH2. So this is called primary amine. Similarly, if you take excess of Rx, that is if you take two equivalents, this is only one equivalent. If you take two equivalents of Rx with alcoholic NH3 at 373 Kelvin only in sealed tube, both the reaction is carried only in sealed tube. So what you get? R bond NH bond R plus 2 HX. So observe here there is a two halogens and two hydrogens from here becomes 2 HX. Similarly, if you take 3X in the same condition, under same condition, that is with alcoholic ammonia, and same conditions, that is alcoholic ammonia. So what you get here? R N bond R plus 3 HX. Okay, this is primary amine, this is secondary amine, this is tertiary amine. So similarly, if you take four equivalents of Rx with alcoholic ammonia under same condition. So what you get, what you are expected here, this is tertiary amine. So here what you expected, after tertiary there is quaternary, that is quaternary amine, that is R bond, N bond R, and write one more R. During that time nitrogen carries positive charge because electron deficient. Plus what you get 3HX becomes 3HX becomes here observe how many halogens are there? 4 halogens. But how many hydrogens are there here? 3 hydrogens only. Therefore you get here 3HX only. And the next halogen becomes here, that is X minus. There is one positive charge, one negative charge. You get salt, that is quaternary salt. Quaternary salt. Okay, this is the reactions with ammonia. So similarly, write example for quaternary ammonia in place of R by taking methyl. Okay, I hope you understanding. You should write in place of R taking methyl example for quaternary reactions with ammonia. Finally you get methyl amide, that is tetramethyl ammonium salt. Okay, just in place of R you should write CH3 and complete this whole reaction, that is homework. Then the fifth chemical reaction is reactions with water. The fifth one is reaction with water, that is H2O. We also call as solubilisis. Solubilisis. This process we call as solubilisis. So in this process, alkyl halides OH is treated with water H2O to get observe one hydrogen and one halide becomes what? HX. The remaining thing is carbon OH plus HX. So what you get? Alcohol from alkyl halide. Right. So similarly, take example. So in place of R, write CH3. CH3 bond in place of HCl, that is chloromethane plus water. What you get? What you are expected here? CH3 and OH plus HCl. Its name is methanol. So the methanol is obtained from chloromethane or methyl chloride. Similarly, write one more example or complete this one. CH3 bond CH2 bond place of chlorine iodide bromide Br ion. So what you get? Take this is homework. What you are expected, complete this reaction. Okay. Then next one, reaction with the next one, reactions with sodium alkoxide. This is the general representation of sodium alkoxide, NaOH. This is also called as Williamson ether synthesis. Williamson's ether synthesis. So in this reaction, we are going to synthesize ether from haloalkanes with sodium alkoxide. That is general reaction. Take haloalkanes Rx, which is reacts with sodium alkoxide, that is the NaOH. So let's take our convenient R dash. So this is R. Because if you take R, we didn't get confused, right? So that we are taking R dash. So in place of ether, sorry, not ether, no solvent. In this treating with these two, you get NaX and RO R dash. That is RO bond R dash plus NaX. So what is name? Ether. You get ether compounds from what? Haloalkanes. So similarly, take this is homework. In place of R, CH3 bond Cl plus NaO. In place of R dash also I write CH3. Okay. Take homework. What you get finally. So I write here NaCl. So here what you get, you should write. And similarly, I will solve one more example. This is homework. And the second example, I write here CH3 bond CH2 bond Cl. That is what? Chloroethane, which is treated with NaOCH3. That is sodium methoxide. Sodium methoxide. Its name is sodium methoxide. Sodium, that is sodium methoxide. And you know, this is chloroethane. So which is on 3D. What you get? Na and Cl becomes NaCl. By understanding this equation, you should write this one. Okay, you can solve definitely. So what you get? CH3, CH2 and OCH3. That is CH3, CH2, OCH3. So what is name? Methoxyethane. Methoxyethane. Okay, the longest chain is treated as parent and the shortest chain is combined with oxygen, and we are pronounced as alkoxy, like the methoxyethane. Methoxyethane is the name. Okay, so this is the reaction with sodium alkoxide. Then the next one is reaction with silver carboxylate. Silver carboxylate. So the next one, reaction with silver carboxylate, that is RCOOH is the general representation of silver carboxylate, and this whole reaction is called as Ernst-Dicker reaction. Ernst-Dicker reactions. In this reaction, take haloalkanes, it is general reactions. Haloalkanes is treated with silver carboxylate, that is Hg. I am writing this one like HgO. This is written reverse HgOOCr. Okay. So if you get confused, write like that only. That is RCOOH in presence of ether as a solvent. Ether is solvent. So what you get? Ag and X becomes what? AgX, and the remaining is COOCr, because here only the atom eliminated, so that you should connect O with R. So what you get? To avoid the confuse, write here R dash. So what you get? Write this one first. R dash COO and R. Okay. R dash COOR. So its name is called as ether. Plus the remaining is AgX. Okay. So this is called as Ernst-Dicker reaction. Now take example. So write in place of CH3 bond in place of HCl plus in place of R dash CH3 COOH in place of ether. What is name? Silver ethanoate. Silver ethanoate. Ethanoate is the name of this compound, and you know chloromethane. So what you get is silver and this chlorine becomes silver chloride. AgCl. And the remaining thing is CH3COOCH3. CH3COOCH3. So its name is methyl ethanoate. Here observe there is silver, so we call silver ethanoate. In place of silver, what is there? Methyl. So methyl ethanoate. Methyl ethanoate. So similarly, take homework. CH3 bond CH2 Cl. Chloroethane, which is reacts with CH3 COOH, that is silver ethanoate in the presence of ether, and write the product. You get the byproduct is silver chloride. So complete this one. Take homework. Then the next chemical property is, the next one is reaction with potassium nitrate. Potassium nitrate KNO2. Potassium nitrate. So here the alkyl halide, general reaction RX. This alkyl halide is treated with the potassium nitrate NO2. potassium nitrate in presence of alcohol, that is alcoholic potassium nitrate, alcoholic potassium nitrate. So you get alkyl nitrile compound. Alkyl nitro compound, that is R bond. This K and X becomes KX, and you get a compound like R bond O N O. You should write like that. R bond O bond N O, like that only you have to write. You get alkyl nitrile compound. Alkyl nitrile. You get alkyl nitrile. You should write like that only. RNO. Don't write RNO2 here. Don't write RNO2. You should write RONO like that. That is called as alkyl nitrile. And take example. In place of R, CH3 bond. In place of X, take chlorine plus alcoholic KNO2 potassium nitrate. What you get? And K and Cl becomes KCl, and the remaining thing is CH3 bond O NO plus KCl. So what you get? Methyl nitrile. Okay, because only one carbon, and this is called nitro group, methyl nitrile. So example, second one, take homework. CH3 bond CH2 bond Cl plus alcoholic KNO2. So write what you get here and write the name of the compound. So this is the reactions with potassium nitrate. Similarly, the next one is reaction with silver nitrate. Ninth one, reaction with silver nitrate. That is alcoholic silver nitrate, AgNO. So here, when we are treating with alkyl halides with silver nitrate, that is AgNO2, to get compound AgX, that is AgX and RNO2. So here you don't get RONO, however, rather than you get RNO2. So nitro compounds of alkane, that is alkyl nitrile, becomes nitro compound of alkane, that is nitroalkane. Similarly, example, methyl chloride is treated with water. In place of potassium, write silver. So what you get here? AgCl, and here ONO becomes water, NO2. So you should remember what will happen when we are taking silver nitrate and potassium nitrate, and also silver chloride and potassium chloride, told in beginning only. So what you get here? CH3NO2. What is name? Methyl nitro or nitromethane. Similarly, take this is example, that is chloroethane is treated with silver nitrate, alcoholic silver nitrate. What you get here? Product and silver chloride. Take homework. Okay, then the next one is reactions with lithium aluminium hydride. Reaction with lithium aluminium hydride. LiAlH4, lithium aluminium and hydride. So here alkyl halides is treated with lithium aluminium hydride. You get lower alkanes. So observe how many hydrogens are there here? 4. Therefore, take 4 equivalents. So that you get 4 equivalents of R and hydrogens becomes 4 RH. Okay. Plus the remaining thing is there is 4 halogen atoms and lithium and aluminium. 1 lithium and halogen becomes lithium halide. and aluminium, and remaining 3 halides is aluminium halides. Okay, this is the balanced chemical equation, that is reduction of alkyl halides by using lithium aluminium hydride, and also we called as reactions with lithium aluminium hydride. And take example. So in the example or place, take CH3 and in place of X Cl, write here 4. So take lithium aluminium hydride is the reagent. So what you get here? CH3H, 4 hydrogens. Here 4. What it means? CH3 and H becomes what? CH4, right? This can be written as CH4. What is name? Methane. That is lower hydrocarbon. Means the first hydrocarbon of alkane. Plus, so that in this reaction you get lower hydrocarbons. That is lithium chloride. Then the byproducts is and aluminium chloride. AlCl3 and lithium chloride. This is what? Methane is the main product. So similarly, take homework, that is CH3, CH2, bond Cl. Take 4 equivalents, which is treated with lithium aluminium hydride. So complete the reaction. What you get? Write all these 3 products. What you get? So similarly, the next one is reaction with organolithium compound. That is 11th one, reaction with alkyl lithium or Li. Reaction with alkyl lithium. Just in place of lithium aluminium hydride, they are writing Li. So what you get here? Rx becomes treated with lithium alkyl lithium, branch of alcohol. So what you get? This lithium and this halide becomes halide. So for our convenient, write here R dash. So what you get? R dash and R and R dash. So here we get higher alkanes. In the last reaction, means reaction with lithium aluminium hydride, you get lower hydrocarbons. But in the case of alkyl lithium, you get higher hydrocarbons. So let you know in this example, how do you get higher hydrocarbons? So we are taking here methyl chloride. Take 1 equivalent only. Methyl chloride, which is treated with CH3 bond Li. That is methyl lithium. Its name is what? Methyl lithium. That is alcohol. So what you get? Lithium and Cl becomes here lithium halide, right? So you get lithium chloride. And the remaining thing is CH3 bond CH3. Okay, you get ethane here. In the previous example, you get methane. Here ethane. In place of methyl group, you take ethyl, propyl or isopropyl pentyl, any group, you get higher hydrocarbons like that. Complete this one. Take homework CH3, CH2, Cl, which is treated with, I write CH3 bond CH2 bond Li. That is ethyl lithium hydride in presence of alcoholic condition. So what you get here? Write the products. So here the chemical properties of in the chemical properties, nucleophilic substitution reactions of haloalkanes is complete.